Thanks everybody for being here. I'm gonna turn this on so y'all he works by the end of the week too. If you can't hear me, let me know. I'm usually pretty loud. Not as funny as Rusty, but I'm twice as smart. That makes up for it, right? And prettier. That's what I tell Rusty. Some of us are funny, some of us are pretty. Come on in. Last one in buys lunch or dinner and drinks. All right. So this is part 2 of a 2-part training that we do at Kysor Warren. So if you haven't seen part 1, Ignacio did part 1 this morning in the other room. He has 2 more sessions, one tomorrow morning and one on Thursday morning. So if you didn't get a chance to see that, please back up. It's okay to do them out of order because they don't necessarily feed off one. He does the theory and the engineering and the history of CO2, why we're using CO2, why we picked that. So if you get a chance to see that, that's introductory to CO2, Kysor Warren. I think it's at 9 o'clock in the morning. Okay. A little bit about me. I'm Dale Sizemore with Kysor Warren. I start my 30th year with Kysor Warren in June. Yes, that makes me really old. I've been in refrigeration since 1982. Do the math for you, that's 42 years. So I forgot a lot of stuff over those 42 years, but I learned a couple of things too, and we'll try to share that today. First question is, who is the most dangerous mechanic or technician in the room? No, it's the one who thinks he knows everything, right? I'm not that guy. So if you have questions, this is for you. We're always learning new stuff. I learn stuff every show we go to, every training event we do. We've done thousands of hours of direct training for these CO2 in the last few years, specifically CO2. We do a lot of podcasts. We do a lot of different things. So you're always learning something from everybody. Albert Einstein said, a little bit of knowledge is what? A little bit of knowledge is dangerous, okay? But if you have a lot of knowledge, it's not as dangerous. So if you know a little bit about CO2, it can be dangerous. You need to know it. You need to learn as much as you can. That's why we have these events. That's why these events are free to the technicians. And we come here as vendors and industry people to pay for sponsorships to be here for you so you can get this training for free. So get as much as you can. It's for you guys. And please, if we go really fast, this training is just a condensed version of a much bigger all-day course. Ignacio and I, we can do 7 or 8 hours on this stuff. So you can't learn everything there is to know about TCO2 or CO2 or any part of that CO2 in a couple hours. So we're going to give you the Cliff Notes version. We will be, I'll show you at the end of the slide, we have 2 fully operating training centers. One's in Orange County. It's about a 45-minute, 50-minute drive south of here. If you get a chance to attend that, please come by. Those are all-day hands-on with operating equipment. And we just started up, and we're working on a calendar right now for our training center in Columbus, Georgia, which is at our home office, at our plants. And that one is fully operating equipment as well. We have classrooms, we have cases, we got walk-ins, we got stuff operating, and you get to see how to start them up, pump them down, do all the different things we do. So please stop me if I go too fast. We'll fire through some of this stuff really fast. So if we go, just raise your hand and we'll back up and slow down. And we'll be around the show all 3 days. So anytime you see us at the booth or the table, if you have questions that you don't ask in here, please come see us. And we'll try to help you out. All right, we'll talk a little bit about, I'm not going to go through the agenda, but we're going to talk about case setup first. And if you guys sat through Rusty's and some of the classes this morning, you hear a lot about CO2. How many of you in here already work with cases, with case controls? Electronics, okay? Most of the room, because this part of the country is a lot of that, right? How many of you in here have any CO2 experience at all? Liquid overfeed or transcritical? Okay, a big part of the room, good. But, so we teach this class, the majority of the time, especially on the East Coast, the class is mostly newbies, right? People because there aren't that many systems out there compared to here. So what we always try to reference to folks is it's not that hard. If you're already good at parallel refrigeration, then the jump to transcritical is very short. Because if you already work on case controllers and electronic valves, it's a lot shorter put. So these valves, the case controllers and the valves are basically the same thing as used before, just size for CO2. Let's stop this with the feedback. Again, the transducers still look like regular transducers. They may be at a higher pressure, but it's the same thing. Case controllers, there's the same, a lot of them are the same case controllers as before, just now they have CO2 as an option to pick in there in the settings, and the defaults or would change for that as well. So not a lot here. The biggest change is the only new thing up here that wasn't needed before TCO2 or liquid overfeed was the bypass check. We'll talk a lot about that today because we talk a lot about safety. And I'm going to show you what happens if you're not safe. But if we always have to vent all the pressure, any pressure increase out in the store, out where the public is, back to the rack. So we don't have any garment changes and events inside the facility where we're trying to sell groceries. I'll steal that from Rusty too. But this integrated check valve has been around for a few years now. When we first started doing TCO2, we didn't have that available. As soon as it was available, that's our standard. As long as we can get them up to the size, there's a size max, I think it's 1 1/8. We can get those up to anything above that. Then you have to build a bypass check around the equipment to be safe. We'll talk a lot about that in detail. So this is a standard case layout, a legacy case for us at Kysor. Liquid line, suction line, mechanical expansion valves. Got a few options down here. You can't see it in the picture probably because it's dark. There's a hand valve, liquid line dryer, and a solenoid. So those are all options you can get with any case you buy. But this particular case pretty much has all the options, right? When we go CO2, the only difference is we change the isolation. That other valve had a hand valve on the liquid line. You can put a ball valve on the suction line, it's optional. In CO2, those aren't optional anymore. They come standard, so we have isolation for that case. But when we isolate the case, we isolate any part of the liquid side of the CO2 system, we have to protect that against pressure increase, right? Too much pressure. These coils are rated around 600 pounds, so we're going to protect the case. This is the option we talked about before. This is our standard. As long as we have those available, that's what's in the cases. But if you don't have that available, or you don't have one at the local supply house, or you are on an emergency call and you need to do something or add a thing, most of you have the components on your truck to build the bypass right off your truck with standard components. So this right here is 2 magnet checks, and all the arrows point back to the rack. Everything always points liquid line and suction line, and then you put 2 standard ball valves as long as they're rated working pressure over 700 pounds. So most of you have those components on your truck already. And you can build that in any size just for the bypass. You just have to match the liquid line and the suction line on the ball valves. You don't want to put 3/8 on a 7/8 liquid line or something like that, or suction line. So does that make sense to everybody? Which way do the ball valves check? Point? Yes, please. If you don't remember anything else, remember the safety features we give you today, because that's important, because we want to keep the gas in the rack, and we also want to keep everybody safe, right? I will show you examples of what happens if you're not safe. So unit coolers and cases, everything's the same except for the coil and the coil circuiting. CO2, typically you'll change the distributor setup. It may be the same coil blank, but the distributor tubes and the bypass, the passes on the end, a lot of times they'll go from 4 or 5 distributor tubes on a standard DX case to 2. It's just because of the efficiency and the way that the CO2 is laid out. I'm not sure, but you see a change in the thing. So you can't flip-flop back and forth between RX and or DX and CO2 on the same coil, even if it's the same blank. The load, the fan, the velocities, carburetor's back. The velocities, the defrosts. For the most part, and we'll talk about the difference, the defrosts are the same. We still have to do the same BTU load in the case. The case doesn't care. It doesn't care whether it's R744 or 408 or whatever, 448, whatever you have in there before. It doesn't matter. Oh, back up, wrong way. So that's all we're going to talk about cases today. I will reference some defrost settings in a minute, but all the equipment that we produce is ANSI and ASHRAE. Those are your safety standards, UL and NSF and all that stuff, which is the same as before, because we use the exact same case frame for DX's CO2. We just changed the internal components. Piping. Oh, disclaimer. So if you're an install contractor and you got a customer with a customer spec, I tell you always default to the customer spec. What we give you today is what the minimum requirement or the minimum recommended things are for piping and practice and hangers and clamps and things like that. All that is our minimum recommended requirement. If you don't have a customer spec, then it's good practice to do this, because we learned the hard way early days of CO2. Everything in the CO2 system is cold. The liquid line going to your cases on a TC CO2 system may only be 35, 36 degrees. If you're in the south or somewhere more humid than here, what's going to happen? That's going to sweat. You know, we're going to have water. We're going to have ice in the suction lines. The return temps are about the same. They're the same because evaporator temps are the same, right? So we recommend a 1-inch minimum on both the liquid line and the suction line. That's a safety factor. If your customer says, yeah, it's 1/2 inch and 1 inch or 1/2 inch and 3/4, that's fine. But if you call me or one of our guys and say, hey, my stuff's sweating and dripping on the floor, the first thing you're going to check is what the installation's on there. So just be aware. This is the knot chart. We're not going to go through all these slides. This is important information. You'll see it multiple times in different ways today, but which parts of the system are different and which parts are the piping are different. Kysor, and most of the vendors, I think, we try to minimize the amount of the high pressure piping that you have to do in the field for complexity's sake and cost and things like that, because the more of that stuff you have, the more chances you have to make a mistake and the expense goes up even higher and higher. So we try to minimize that space where we have to have the high pressure copper. So we haven't talked about the high pressure copper yet, but let's do that. So the medium temp discharge is your highest pressure in the system. That's the discharge from the compressors to the gas cooler. We call it a gas cooler. Why? I've been here all day. Most of you know, right? We used to call it a condenser, but because we're not always condensing, we call it a gas cooler. It is a condenser part of the year, but the middle of summer, South Georgia, where we live, there's not much condensing going on. A little bit of subcooling of the discharge gas, that's it. So the operating pressures you see, maximum pressures, these are maximum pressures, not operating pressures, but where we have to have the special copper. And everybody know what, are familiar with K65 or XHP. Those are mild. If you've done a lot of CO2 installs, you're already familiar with that stuff. Anybody that is not, we have a little show and tell, but we have to use those on the parts of the system that are over 90 bar. So we use them on the discharge lines. We use a few places on the rack. Some of the new racks even have stainless steel headers and things, so you don't have to worry about that. You can even go higher than K65 because they're big, 1.5 inch, 1.8 inch. The difference between K65 and regular AC&R copper is very evident if you're holding them in your hand. If you hold these two pieces of 7/8 in your hand, you can physically tell which one's which. But if it's mounted on the rack and it's got fittings and it's solid in the rack, how do you tell? These markings are all rubbed off. There's no markings. So how do you tell that they're magnetic, right? So we have these handy dandy little magic service tools. And this is the exact same thing we test them with in the plant with QA, but a magnet won't stick to 100% copper, but it will stick to K65 or HXP. So we'll pass those around. One is AC&R, one is K65. But again, if you're holding them in your hand, you can tell. If you're holding the fittings in your hand, you can tell. If you got a 7/8 fitting in one hand and a 7/8 XHP fitting in the other hand, you can physically tell. The other, yes, sir.
Still braze them or just?
Yes, we'll talk about exactly how we fit them together, because by going this route, and there's also some other stuff on the horizon, some different technologies with heavier duty copper that's not iron infused, 2 or 3% iron in content. that they're working on that they say is out there. It's not available yet, so I'm just telling you what may be coming. But the other option is, like a lot of times in Europe before they could do this, and in some places in Canada where they will not allow K65, they have to run stainless steel. So when you go to stainless steel, you jump industry, you jump trades, right? So how many of you can certify weld stainless steel pipe? Yeah, nobody. That's usually the response you get from a group of refrigeration contractors who never had to do that. But if I have to run pipe in my store, even if it's 60 feet between the rack and the gas cooler, and it's not that, you would have to run stainless steel. That's your two options. And that gets really expensive. Not the material so much, because that material is expensive. We didn't even talk about that. That's the other reason you want to minimize it. It's 2 or 3x per foot what AC&R copper is. And oh, by the way, don't try to take it to the scrap yard and get scrap where it's heavier, because they give you a lot less money on scrap too. So it's a double negative, right? If you take, the scrap yards are onto that. They use these same kind of magnets to tell what kind of copper they're getting back, because they caught people turning in barrels of K65 and they couldn't do anything with it because it was mixed metals. It wasn't copper. So again, the operating parts of the system, we didn't talk about. The medium temp discharge has always been the highest. The high pressure valve outlets are 655 rated, flash tank 655, medium temp suction line 655, and so on and so forth. And then the low temperature suction at 435 on the suction side, but that's not what it runs. Those aren't the operating pressures. These are more your operating pressures. These are the ones that are important to you as a service tech, because most of the racks, most of the commercial CO2 racks today have some analog gauges on there. They just have a dial, a stainless steel dial, high pressure. Some are in bar, some are in bars and PSI, G. But these are the ones that are important to you. And we do a little cheaters. A lot of the guys will do cheaters when they do a startup and they got an analog gauge on there. They actually take a Sharpie and mark the range where they want to be, so they can just walk by and look. And if I'm at my gauge needle's in between those two ranges, I'm good to go, right? So the low side, 188 to 218. If you have a pressure temperature chart in your pocket and you cross that over, that's about minus 10, minus 15 suction pressure. Sounds crazy, right? It's 220 pounds, almost 220 pounds, and that's your low temp suction. That's the lowest pressure on the rack. It's the lowest operating pressure on any TC CO2 rack. Come on in. Last one in, bond beer after this.
I got it.
All right, good. Uh-oh. You're off the hook. We got three more volunteers. So again, the low side, 188 to 18, the intermediate stage, 377. And then also the high side. The high side again, the high side is 652 to 1495. Why is that so wide? Because the discharge matters why. I mean, why is the discharge range that high? The ambient, exactly. You know, we get a question a lot, the question we all get is, if I have a shutdown, how long is it going to last? Well, it depends. If it's 80 degrees in Southern Cal and I do it right, I can probably get most of the day. If it's 100 degrees outside in South Georgia, I got minutes if I don't do anything special. So it does depend, and it could be anywhere in those operating ranges. Normally when the rack's running, it can be in those ranges. So if it's already running 1495 and the power goes off, guess what happens? It can go even higher than that really quick. So something to know. We already talked about this, but and this is not an evaporator hanging in a walk-in. This is a downward view of a gas cooler on the roof. It's an air-cooled gas cooler, and that's the only place for the field piping, and it's all copper to copper. The rack stubs are copper, K65, and the gas cooler stubs are K65, and we run K65 for the discharge and the return. I call it a return. Why? Because it's not always liquid. So all the normal piping practice, this is the easy part. If you're already a pipe fitter and you already run copper to copper, all the normal piping practice still apply. Some are more important than they were before, but they're still the same piping practices. A good piping practice is a good piping practice, right? So where you put your clamps, where you support the line. You don't want dips and bends. You don't want to trap lines in between two solid pieces that they can't move, they can't expand and contract, things like that. You got long runs, you got to allow for expansion and contraction, just like you did before. K65, although it is super strong and holds 2-3x the pressure of regular copper, it is very stiff. And being so, it can be very brittle. So it doesn't like to be in a bind. It doesn't, I mean, honestly, if you ever held a piece of 1-8" K65, a 20-foot stick on your shoulder by itself, it won't hardly bend. It doesn't even bounce when you walk. It just looks like a solid steel rod sticking out there. It's heavy, right? So, yeah, all the normal piping practices are the same. The pro tip, just because it's CO2 at a higher pressure, higher velocity, doesn't mean you can get away with anything. The traps, the oil return, the slope back to the rack, it's probably more important than it was before. Why is that? Because the components are way smaller, the piping is way smaller, my oil charge in the system is way smaller, so it takes less of a problem to, if I got oil migration or I got oil trapped in that system somewhere, it's not coming back. True story, happened not too far from here. Many years ago, they installed a store and they said, oh, it's CO2. It was one of the first ones in the area. It's probably 15 years ago. And they said, oh, it's high pressure, plenty of velocity. We don't need traps. It was on the piping diagram. That's an expensive experiment. About a week after the rack started up, the compressors were all shutting off on oil failure. I think we eventually lost one of those compressors. Because then we go back and look and there's no traps anywhere in the store. They had to go back and add them all back. So oil traps are very important. I throw this in because this has been wrong for a long time. You'll get a room full of contractors saying this way is okay, but that is not the case. That is the correct way to do it. And you reduce it on the riser. If your riser is reduced, you don't reduce, you keep the trap the same size as the horizontal, so I don't trap any oil going in. I want to make sure that I minimize that trap size to have the least amount of oil trapped in there as possible. As the oil builds up, I increase velocity. As I increase velocity, I'm going to start bringing that oil back. I don't want any more oil out there uncontrolled than I have to, right? Because my oil separator is smaller, my compressors are smaller. The oil charge on a CO2 rack for 200,000, 300,000 BTUs is probably half of what it would be on a DX rack of the same capacity, right? So I don't have the luxury of, Rusty told a funny story today about the guy that, put in 3 gallons of oil at startup and 2 gallons of oil the week after startup and 3 gallons the week after that, and then 2 weeks later he took out 15 gallons. So it's eventually all going to come back, and compressors and they don't like oil. They don't like oil. CO2 compressors, although they're very tough and very durable, they do not like liquid of any sort coming back to the valve plates. They're very small, but they go away very quickly. And they don't make much noise. They're so big and heavy, they just, that's it, gone. Oh, slope back to the rack, super important. Just like we said before, here's a pro tip. When you got a store full of 1-inch insulated, very small lines, the average size of your loops is less than 7/8 or less, right? For most of the loops in the store, the liquid lines and the suction lines are usually smaller than, every once in a while you'll get a big store with maybe 1-8" or 1-3", but most of them are much smaller. So when you're in those small lines with 1-inch insulation, you got a bunch of 3/8 or 1/2-inch liquid lines, and I got 1-inch insulation on there. You got to make sure they don't dip in between every hanger. So you got to put those hangers close enough, and one way to get around that is to add, we finished talking about oil traps. We talk about the difference between all the normal piping applies. If I have over a 15-foot rise, I put a double trap. If the EOR or the piping, whoever has designed the piping, recommends a double riser, double trap. We've never seen that in TC CO2, but that's also a possibility. But this is a double trap riser with inverted. I will tell you that in a perfectly piped system, you can probably get away with inverted, but a lot of customers specify that because they got burned with free-flowing oil coming from a riser, going back down the oil. We did a podcast about that last week, about that. So if your customer specifies inverted traps, by all means, you got to put inverted traps on everything. But if you got good piping practice and everything slopes back and nothing can free flow back down the pipes, you probably don't need it. Again, We re-emphasize the isolation valves. All these valves do, and we said before, when I put the bypass checks, I'm going to isolate the load, which is the evaporators. I'm going to put one on the suction line, one on the liquid line. Which way do the arrows point? Back to the rack, exactly. Oh, you go, let's get an A. These components, like I said before, just standard. This is just a standard magnet check. Most of you have it on your truck. Most of those are rated for 600, 700 pounds at this point, so you can use those. You don't need a big bypass line. You can have a 7/8 line with a half-inch bypass around it. It'll let the pressure go through. It's not like I'm flowing refrigerant. I'm just relieving pressure. So, and if you have these guys over here, again, there's nothing. The only tip you get there is there's an A. There's not an arrow. There's an A on those spoiling valves. That A has to point towards the load, which is the evaporator. So that means it kind of creates, sorry. First time with this new pointer, my other one died. It looks like this thing makes a point, but actually the flow, when it's under pressure, the flow is going this way. The flow is coming out here. So the check valve, if you look at it logically, the check valve, when my pressure builds up on this side of the valve, there's a spring-loaded ball check right here, and as the pressure builds up, it opens that. Once it gets a 5-pound difference from this side to that side, and when this valve is closed, I open the ball check and the gas bypasses around the valve. So super important. You know which way the arrows point, regardless of which one you use, which one you build, and we'll be safe. We'll be safer there. PRVs, pressure relief valves. Pressure relief valves have been a learning for all of us with CO2. You've all seen this guy, right? You've seen these for 100 years on every receiver ever built had 2 of these on there with a triple tree, right? 502, 448, all those, they're usually 500 or 600 pounds. They're only to protect that receiver if you pump the system down or for some reason you've isolated that receiver with too much gas in it. I didn't leave enough vapor area in that receiver and I shut it off. It's out in the sun on the roof and the pressure builds up and blows the pop off. That's about the only time you ever see it in a traditional system, right? It can stand still indefinitely as long as I don't overfill the receiver more than about 80%. But CO2, not the case. You heard a lot of people talk about it. Losing CO2 or having an event because it's not a one-time ever thing. It's usually not one time unless you're standing there and it happens and you fix it before it happens again. An event can be 2 or 3 pop-offs. It can be 20 pop-offs. Eventually, the system will equalize and it'll get below the standstill pressure and it won't pop off anymore, hopefully, if the PRV resets. So these are the traditional ones we had on the old racks, and we still use a few of these, but these are typically vapor only. This is super important. If you're replacing a pop-off or you're adding a pop-off to an isolation point in a system, you got to make sure you know if you're putting it on vapor only or vapor and liquid. If you run liquid CO2 through a vapor only pop-off, it's probably going to work once or twice, maybe, if you're lucky. Again, learn the hard way. We had the first test racks we did were 15, 16, 17 years ago. They had pop-offs everywhere. And most of them were vapor only because that's what you could get the right pressure ratings. And they'd pop off once or twice and then we had to replace them. Okay, I got to blow the charge. I got to do the thing. Some of these aren't redundant. So the main pop-offs on the rack, what we did was we went to a higher capacity, higher duty cycle pop-off. This guy right here, and these are typically made by FlowSafe, and we got one other vendor. I'm not touting anybody's thing, but FlowSafe seems to be pretty reliable. And these guys are up to like 1,500 cycles of clean refrigerant. You sit through Rusty's class, you talk about the oil. There's oil comes out, there's liquid CO2, vapor CO2, and anything else that's in there comes out. And they typically, when we have them returned for service, the report comes back that the seat's damaged. And the seat gets damaged by liquid CO2 and debris coming through there. It's a very violent event. I will tell you, if you're standing next to it or under it, the pro tip, I was sitting in a chair in our lab with my back to the rack about 5 feet away, and there was a problem where it was first day of startup, and the little pop-off on top of the oil reservoir went off. That's a garment changing event. I about broke one of those chairs. It's kind of like those and try to get out of the way. The chair went flying one way and I went flying the other way because it was like 5 feet behind my head and it's loud. It sounds like a gun going off. Don't. But what you want is, it's super important. We'll talk about it later when we get into the rack startup, is making sure that system's good and clean, the oil's good and clean, you've replaced all your filters, you've done all your evacuations and things like that, because any debris that gets in that rack will damage stuff like this. It will be unreliable. So we've seen some of these pop-offs go 200-300 times and they're still working fine. And you see other ones that go 2 or 3 times and they got debris stuck in there or the seat's damaged and now I got to replace it. And they're super expensive. These are actually serviceable. You can take them off. They're calibrated. They got seals on top. You can send them back to the manufacturer. We put them on a triple tree on the mains so you have redundancy. You always have one or the other. So if I have one that's leaking, I just switch the valve to the other way and then take that one off and replace it or get it serviced and put it back on. Hopefully you make it till you get it back. But you can send it back to them. They will rebuild it. They will give you a report and they will send you back the valve calibrated, recertified, and resealed. And then you just screw it back on with the correct install up there. Somebody asked earlier about K65. K65 in every way, except it's thicker. The obvious things are it's thicker and heavier, so I got to put more heat to it, right, for the same flow. If you got a normal tip that's good for up to 7/8, it may not be big enough for 7/8 K65 because it's heavier. It's just like doing bigger pipe, right? So all the piping practices, the capillary fill, all that's the same. There's only one little difference. K65 has iron in it. XHP has iron in it, has that iron content. You cannot shock a red hot joint with a cold wet rag or anything wet or cold. You cannot shock when it's red hot. That's a common practice. We had to go through and retrain all of our brazers in the factory. We started using this pipe because the manufacturers warned that of the pipe and the fittings, if you shock it, you shock the two metals, the copper and the iron, and they will contract and expand at a different rate. And you can cause fissures. And those fissures may be microscopic pinhole leaks that you may never find, but they always will leak. Or if you're lucky, it'll be a big leak and you'll find it right away because there's no little big leaks in CO2. You can hear them. There's enough pressure, they're making noise.
So what do you do? Just let it cool down on its own?
All you have to do is you let it cool down naturally. What we recommend, like to the guys in the plant, what they would do is they would do a joint. They have 3 joints in here. They do one joint and reach in the bucket. They got a 5-gallon bucket with 100 rags in it, and they'd spin it and wrap that rag around a red hot joint. As steam come out, and they go to the next joint and start brazing. So by the time they finish, these were cooled and ready to use. So what you have to do now is, if I have 3 joints or 4 joints or whatever it is, go ahead and braze them all. Let them naturally cool. Once it's turned black, you can wipe it down when it's still warm. But if you can't touch it with your hand at all, it's too hot. That's just the rule of thumb. That's what they told us. And I believe there's some literature out there about that from Streamline and Mueller and stuff as well. So I don't think we have any of them here. But it's just a good practice to do that. Also, the annealing of the copper. That copper is super, super heavy duty. It is not flexible. So if you anneal a part of it, that part becomes flexible. That's where it'll shear off. If you have anything, too much vibration or a line trapped, it usually will shear right in front of the braze joint. Not the braze joint, but right in front of the braze joint, because that'll be the weak spot from brazing. We've seen a couple discharge lines, that happens too. So we talked about trapping liquid CO2 and which way the arrows point. Okay, what happens if you use the wrong materials or the wrong piping, or we don't put a pop-off around the thing pointing in the right direction? Yeah, it's a garment changing event again. I'll steal that from Rusty. You know where it came from? So we got. I usually disclaim this. I don't know where it is. I don't know where it came from. I got the pictures. So this was a bad deal, right? So some combination of problems. That pipe you see right there was inside the unit. That's fill piping. So that fitting, that's not part of the fitting you want to normally see when you go on a job site. So the inside filter housing and the thing, the unit was totaled. It was destroyed. They said they had to replace the whole thing. It was rebuilt. They did rebuild it, but it was all total rebuilt. Yeah, right. I'm sure they didn't. Yeah, it's a bad day. It's a really bad day if you're standing in front of it when this happens. Because there's shrapnel parts. There were shrapnel parts come out of this thing. Oh, wait. Oh, yeah. So there's parts of fittings and pieces and pressure controls. There's one more. We're hitting the wrong button. It's a very bad day. So you see the copper shavings. That's the header. Took all the distributor passes off. Just sheared them off. There's another big hole in the sheet metal back here, and I don't know what that is. Is it a gauge? Maybe? That one? Airflow? Yeah, I'm not an HVAC guy, so. Trap liquid. And some combination of possibly not the right materials for that pressure. But remember the bypass, which way the arrows point? That's probably all it took to prevent it. It wasn't the right fitting either. But it may have still had a chance. Yeah, there was soft copper mixed in with not K65 and some of the pipe. Yeah, that's not a good mix on that. And that's, by the way, that's a heat reclaim unit, and it's on the high side of the system. that part of the system, depending on what time of year, is running at over 1,000 pounds. Thank you. Back to the leak. There are no small liquid CO2 leaks. This one was a video. I think Russ gave me that one, or somebody gave me that one. Some of my guys are in the room. So when you have a crack on a liquid side of a CO2 rack, what happens? The CO2 escapes, and you see the little white specks there. That is not fireworks. That is dry ice. Okay. So when I have a pinhole, this was not a pinhole. This was a pretty good leak. When I have a pinhole, a tiny, tiny pinhole, like we described before, maybe they didn't quench the copper and I got a little tiny pinhole in the liquid line. As the CO2 escapes, it comes through. It's not 150 pounds. It's not 80 pounds on the backside. The dry ice forms in the hole, and then the pressure builds up on the back of the dry ice and blows the dry ice out. Every time that happens, it's like a little firecracker. You know the little pop-it things you throw on the ground, they pop? That's what it sounds like over and over and over again. Depending on how big the leak is, how fast that popping goes. You can hear that popping noise. Once you've heard it once, you can hear it in a running motor room with all the compressors running inside the insulation. It's very distinctive. So early days of CO2, we kept hearing something. We were in there for a couple of weeks doing startup, and we couldn't figure out what it was. It was a weld on top of the liquid line. It was a weld where it went copper to steel, but it was a bad weld. And we couldn't figure out where the hell the noise was coming. We kept hearing something. Everybody said, "What is that noise?" Because it was muted, because it was underneath the insulation on the weld. Everything was 1 inch or more. So we had to peel back the thing, blow the charge. We found the leak, and it was popping. It was popping every few seconds. It was pop, pop, pop inside of a running motor room. So there are no small leaks on the liquid side. Suction line, yeah, those you're going to have to find the hard way. Soap bubbles or CO2 leak detectors. There are commercially available CO2 leak detectors and gauges now. They're not cheap. So I just bought a set for our lab in Georgia, and they're about $1,000 for a set of CO2 gauges. We talked about the hangers. This one's out of order, but the hangers we recommend are these type hangers. And remember, because the lines are small and the insulation is big, the lines get really heavy. So if I use those saddle hangers that clamp to the unistrut, it shortens the gap in between the hangers by a couple of feet, at least 12 inches, 13 inches, 14 inches. So if my hangers are 8 feet apart and I have these saddles, then the pipe's only exposed to about 6.5, 7 feet, right? And this makes them really stiff and hold together, and they don't move. And you can, like I said, if you ever come to our training centers, we use these in both of our training centers, and they actually bolt that to the rack. If you've never used them before, it's a game changer, because it's a whole lot better than using PVC or metal saddles. All the piping, and again, the bypass check valves over and over and over again. Which way the arrows point? Back to the right. All right. Labeling, flow is important. Knowing your PID. There are things on CO2, and we're not going to go into that type of detail today. In our class, we do a lot more. But there are things that make no sense to you if you've never seen a transcritical CO2 rack, like when I'm dumping the discharge moving this way out of the low temp compressor, and here comes the suction line for the medium temp compressor. You know, and they go up the same T. It's like, that don't make any sense to you. It's like, wait, this has got to be pipe. No, that's where they mix. So they're mixing their, so yeah, there's some things that if you don't know, if you don't study your piping diagram, they won't make any sense. So pre-check. So we've gone through the piping, the materials, and how to install it. We recommend, as a manufacturer, Kysor One recommends a triple evacuation. Like I said, because of the pop-off events and the oil, the small oil charge, it is super important that job is very, very clean. We probably skimmed over it in the brazing. You have to flow nitrogen. We just started up our lab. We were very particular on what we did on this last one. We let it run for 40, 50 hours, and we took the main liquid filter out, and it looked brand new. But everything was done the right way. I mean, they flowed nitrogen on every fitting. They purged the thing. The oil is so clear you can read the newspaper through it. So it's important to do that. If you do that, if you take that time up front, this system's going to run really good for a long time. And if I do have an event, which is almost inevitable, then it's going to reset, and you're not going to be out there in the middle of the night on a Saturday or Sunday changing a pop-off, because those things require a lot more work than just putting more gas in it, getting the rack back up and going after a power outage or such. So we're going to verify all the lines. The popper bracing, we already talked about all that stuff. We're going to make sure everything that's not suitable for a vacuum is isolated. We're going to isolate all the components. Yes, some of the manufacturers and people will tell you that some of the new high-pressure transducers are a lot tougher and more durable than the old ones. Still not a good idea to pull vacuums on it. So we send them, we send ours. I don't know if everybody does this or not. That's why I'm saying we. It's a good practice. We send all of our transducers, whether it be high side, low side, or in a case or in a rack, we send them loose, and they're strapped to the mounting valve, the service valve. We don't use Schraders if we don't have to. Schraders are bad. We didn't talk about that much. Schraders are bad on CO2 for the same reasons we talk about the PRVs, the pop-off valves. If I'm running liquid CO2 backwards or forwards through a Schrader with a little neoprene seal in there, a rubber seal, as you got some of the old school Schrader valves, what happens? It damages just like the seat in the PRV. So it doesn't take much liquid CO2 coming through there, minus 30, minus 40, going across that thing. It becomes very brittle, and then when I clamp down on it or pop the hose off, it may not seat, or it may crack. We've seen a lot of Schraders. Early days, pro tip, we said we've got to get rid of all these Schraders. So a lot of the Schraders have been replaced with just small little angle valves. So now I just have a service valve, no Schrader in it. So whether I'm doing a purge or I'm pulling a vacuum or doing that, you're doing it through a service valve that has a stem on it instead of a Schrader valve. So we've tried to eliminate. There's a few that you can't get rid of on components and things like that are factory installed. It's the best practice not to use those for anything serious like letting liquid in or out. Vapor is fine, but liquid in or out, not a good idea. Don't pull a vacuum through them. That's not okay. They don't work for DX either. So let's make sure that we try to reduce the amount of Schraders. We've seen people go in and add a bunch of Schraders to the new racks. It's like, that's not a good practice. If you want to add fittings, you can add as many as you want. Just put service fittings in there and make sure they can't be isolated or they can't be trapped. We're going to disconnect all defrost heaters. We're going to open all the valves. Because of all the stuff we talked about with the bypass check valves, which way is their point? Okay, so if I pull a vacuum on the rack and I got all the valves in the system opened up, which way do the valves open? The vacuum pump's at the rack. So if I pull a vacuum on it, even though I got the circuit, if I got a random circuit isolated, I'm still pulling a vacuum on it because the check valve is open back to the rack. So you really need in CO2, if at all possible, if you can't isolate the whole thing, or you have to pull the vacuum before everything's finalized or hooked up, or maybe you got a coil missing in an evaporator or something like that, you have to cap the other side of that on the back side of the valves. Does that make sense? You can't just do like the old days, put a piece of tape over it, and shut the ball valves, and then pull a vacuum on the rest of the rack. That's no bueno. It's going to open up. They're going to relieve the pressure back, and I'm going to pull a vacuum through the tape's going to be sucked down the suction line, the liquid line. So ball valve circuit branches, de-energize all the solenoids. Again, those are important things. I'm going to pull it's preferred to pull it on the whole rack. If you have a remodel situation, again, you got to make special precautions for that. You got to mechanically isolate the circuits, anything that's not finished piping hooked up. Those are all good practices. So we're going to check for leaks, of course. We recommend that we, as a manufacturer, our minimum recommendations, and we're seeing a lot of crazy recommendations out there for pressurizing CO2 systems. We recommend a minimum of 300. Why 300? Because 300 is what you can easily achieve with a regular nitrogen tank and a regular nitrogen gauge. We got people out there, we've seen specs come through, they want 600, 700, 1,000 pounds on the high side. Somebody told me 1,500 pounds the other day in a training. I was like, how did you do that? So we took the regulator off, we hooked the hose, we took the hydraulic hose to it, a high pressure hose, and ran it straight to the gas cooler. And just dumped 2 or 3 drums of nitrogen straight in there. That's the only way you can get there, or even close to it. So you can't, the gauge doesn't go but to like 600 pounds or 400 pounds, and it's really hard to get it that high. So 300 pounds is easily doable. It will serve purpose for the leak check. If you do that leak check to 300 pounds and you do a triple evacuation correctly, how many leaks do you have? Zero. How much non-condensables do we have? 0. How much moisture do we have? 0. That's what we want, right? If I have 0 moisture, 0 leaks, and 0 non-condensables, I'm going to have a really easy time on my startup and my adjustment. I'm not going to be servicing the rack before I get it started up completely, right? You don't want to do that. I tell you, I got 3 or 4 guys in the back row over here who will tell you horror stories about going on a startup. They didn't install it. They go there for the startup week, and they spend more time fixing all the problems than they do starting the rack up. We could write a book. So everything we talk about is things we see or have had happen to us. So again, we talked about this. So if we do 300-pound pressure decay and you can hold for 24 hours, it doesn't move more than 1 pound, then the rack, the system is mostly leak-free, not moisture-free. We haven't determined that yet, right? Because all we're doing is dry nitrogen. So we're gonna release the nitrogen charge. The pre-evacuation, we're gonna check the pumps. We're gonna make sure we got a pump big enough to handle it. It's gonna be I think it's on the next slide, 8 CFM pump. I lost my spot here. So the vacuum pump is 8 CFM. It is on that line. It's just fine print, sorry. So it's super important to have a vacuum pump big enough to handle the load and to save you time. If you're going to do a triple evacuation, you don't want a pump that takes 3 days to get to your thresholds, right? If 3 days times 3 is 9 days. Nobody got time to pull a vacuum for 9 days. So make sure you got the right equipment to do that. 8 CFM pump is recommended. We just did the lab, and they had one of those super heavy duty, it was like a 6.5, but that joker pulled the bottom out of it in just a few hours. Because, of course, the system was clean and dry, it didn't have any leaks or moisture in it. So it pulled down really quickly. Chances are, if you put a vacuum, if you have 300 pounds for 24 hours and no more than a 1 pound rise, and you put a vacuum pump on it, it ran for 24 hours, and I'm not even pulling 1,000 micron, what do you think's wrong? Moisture. Most likely it's moisture, or I got a leak that doesn't leak on pressure, but leaks under vacuum, like a missing component on the end of one of my circuits. That's a waste of time. That's a waste of time. So, check for leaks. I'll get everything ready to go. I think I'm going the wrong way again. New pointer, sorry. The other one I was really good with, it had a little. So open all the valves. And we're gonna disconnect, I definitely ain't going the wrong way. It's getting late. You know, it's 6 o'clock East Coast time. It's happy hour. Never use more than one vacuum pump at a time. That's the pro tip. Why? Does anybody know why you can't use more on the same circuit? You can isolate a circuit and use a small vacuum pump here, a small vacuum pump there. Doesn't really work well with these CO2 systems because of the check valves. So why would you use, if I don't have a big pump capable of pulling a rack and a simple on the roof, why wouldn't I take 3 or 4 little pumps up there and do it? Because they're not all the same efficiency. They're not all the same capacity. And what happens is the pumps that they're solid, or if one's a couple of CFMs bigger than the other one, by the time they start getting into deep vacuum, then I start pulling atmospheric pressure through the weak pump to the strong pump, and I'm not doing any work on the rack. You're wasting your time again. It's not a good look. So always use just one vacuum pump, or you got to have the circuits completely isolated. Triple evacuation. First evacuation is very down and dirty. We've dumped the nitrogen charge. We're going to pull that first evacuation probably for a couple of 3 hours, maybe 1,000, 1,500 microns. If I don't get any rise and I don't have any drift, how many leaks do I have? I'm doing the first one just down and dirty. There's no leaks. And chances are, if it's not rising pretty quickly, there's no moisture. Remember, we've already done the vacuum decay or the pressure decay. So we get the first one quickly. Now we're feeling good about the system. I'm not getting any rise in pressure. I don't have to do this very long. We're gonna get it. So once I've done that, approved that, I'm gonna relieve the pressure with nitrogen or refrigerant. You can use vapor CO2. Never put liquid CO2 in there. We'll talk about that in a minute. I know y'all have heard it already or done it. That's a fun experiment, but it can be very expensive in your time. With the second evacuation, we're going to pull that second one down to 500 microns. Okay, if I pull down the 500 microns, that may take a lot more time. We're going to be a lot more thorough. And then if I'm holding 500 microns with no more than 2 psi drift, how many leaks do we have? Moisture 0, 0, 0, right? Redundant. You know, we get calls all the time. It's like, I got a factory leak. The rack's 6 months old. A factory braze joint leak. I said, you got a factory braze joint leak? Did you pull vacuums on the rack and you leak checked it? And yeah. So how did it have a factory braze joint? Oh, it cracked. No, it's not cracked. It's missing solder. It's clearly there, but in the back of your head, you're going, how much stuff is in this rack? That's what I think. It's like, okay, yeah, somebody left a braze joint. That happens, right? But that's why you go through those processes of finding all those leaks to make sure. If you find if you find a leak on our rack before you start it up, there's no question. You get paid to fix the leak, or we come and fix it, whatever happens, or we get somebody else to fix it, whatever it happens. But don't call and say you got a factory leak 6 months after it started and you lost 500 pounds of gas on a leak that's clearly missing because you couldn't have done any of those other steps. Because remember, 0, 0, 0. So I get off my soapbox. The third evacuation, so pro tip, after the second evacuation, has anybody in here ever tried to put oil in an operating TC CO2 rack in the oil separator? Anybody? Yeah. With it running? Without a bypass. I'm going for it deeper and deeper. So it's damn near impossible. Okay. 800,000, right? So if you don't have a bypass is not standard. I think they should be standard, but everybody doesn't specify that. Everybody doesn't want to pay for that. If you have a bypass, then you can isolate the coalescent oil filter, high pressure or low pressure, and then you divert the discharge gas. You leave the rack running. Then I can purge the pressure off the tank, and I can change the filter. I can add oil. I can pump it in. I can pump it out. Whatever I want to do, no problem. But the pro tip is when you're under that second evacuation, before you break that evacuation, use the vacuum to put your oil in the compressors and the separator. I don't even pull out a pump. You put it all in there. Bring the oil reservoir up to 50%, second sight glass. Get all your compressors at the right level. you can add a little bit more to the reservoir, and chances are maybe after you've got everything running and all systems go, running temp, you may, after a couple of days, I know in our lab, we had to put maybe a half a quart, 8 ounces maybe. I wasted a whole gallon for 8 ounces. You know that stuff is expensive. CO2 oil is 85, the standard TC CO2 oil is 85 viscosity, and it is very, very expensive. It's 2 or 3x polyester. So a quart of that stuff costs more than a couple of gallons of the old stuff. So, and they're very proud. They're very, very proud of it. But again, it's hyposcopic. So if you break the seal on one and you don't use, you just need a few ounces, and you just did a whole nother gallon. Especially if it's a couple of weeks after startup, you don't want to use a partial drum on those. So after I break the vacuum, also, pro tip, is I want to put the liquid filter should already be in there. If it's our rack, I don't know if everybody does that still. And put your liquid filters in the rack. After you broke it, after you put your oil in, after you dump the charge, go ahead and put our liquid filters in. Now I don't have to open that system back up until first maintenance or first oil change or first filter change on the oil. So how are we doing on time? We got almost 3 o'clock. We got 30 minutes. You guys are sleepy and tired and ready to go home too. So I think I went backwards again. Somebody yell at me. So after we've done the triple evacuation, we pull down that third micron, that third vacuum. I don't think we talked about that. 300 microns. If I hold that 300 microns with oil, with all my filters in there, with everything put together, this rack is basically ready to charge and start up. I don't have any I don't have any moisture. I don't have any leaks. I don't have hardly any chance of non-condensables, for sure. And non-condensables is not your friend. I know Rusty talked about that in the last meeting they did just before this one. But we've seen horror stories with non-condensables, especially in the old liquid overfeed days, because people were using crap for tanks because they're like, well, I'm not compressing it, I'm not pumping. They were just running it through a pump, right? So we're just chilling it like glycol down to low temperatures and then circulating it through the store. You had non-condensables in there, my pressures are all out of whack, and we go out there and have to purge. We think we got bad tanks, or they were using, the contractors were using tanks that were not instrument grade or Coleman grade CO2, and those, although they're still CO2 and they're probably 90+% pure, they have air, oxygen, nitrogen, they have all kinds of stuff mixed in with them. And that's not good. If you got a little bit of that in 15 tanks that you just charge a rack, you just put a whole 5-gallon bucket full of non-condensables in, it's gonna go somewhere. It's gonna cause a problem. So after we've held that, the 300 microns, and it does not drift more than 100 microns in 24 hours, I'm ready to charge it, I'm ready to start it. So we created, and everything on this, and I know this is our chart, we create a checklist for the contractors because we talk a lot about this in training, you hear a lot about it this week. When you put, the trick with CO2, TCO2 especially, is keeping the gas in the rack. It's really easy to put gas in the rack. It's really quick and easy, simple to put gas in the rack. It's hard to keep it in there. So to keep it in there, I got to keep it running, keep it cold. I got to make sure everything's ready to go when I start it up. And you don't want to have to shut it down unless you absolutely have to. And if it's a planned event, then we can work around that. We can help you with that. We even have instructions for service pump down. In our labs, we pump our labs down, but we have ACUs on them, the auxiliary condensing units, and we have other things that we can do. Put them in service mode, and then we pump them down. We'll let them sit. The one in Orange County sits for a month at a time, not running. But we don't necessarily lose gas. I mean, we burped gas a couple of times when it wasn't pumped down right, but. Yeah, so if you know what's going to happen, but if you just start a rack up or you partially charge it, or everything's not ready, you don't have all your EMS done, you haven't verified all your transducers, you haven't finished, circuits, the plumber didn't put the drains in yet, whatever it is that you may not be able to leave that running, all those are risky. Depending on what time of year it is and how long I've got in between, how long has it got to be off for. So we send the list out to the customers of everything. This one is an eye chart. Here they are blown up a little bit. But everything on this list are things that prevent us from doing a startup when it's time to start that rack up. Most all especially the TCO2, I think every one we've done so far has been factory assist. I don't think we missed any out here anyway. So if we missed them, it's because they were doing it and nobody told us they were starting it up. Making sure your EMS is done. Verifying this, just little things like verifying, and Rusty talked about that earlier too, verifying that the transducer in this case is operating that case controller, and the transducer in this one's operating this case controller, because those two things are switched somewhere, anywhere in the case or in the EMS wiring, it's going to be a bad day.
Or a sensor.
Well, that's what I was talking about. Transducers or sensors. Temp sensors is super quick. I mean, you can check a whole store for 2 cell phones and a bottle of liquid cleaner, keyboard cleaner. That's what we use. Duster, liquid duster. That stuff is CO2. And they just go around, squirt each one, verify that they're on the right circuit, verify the transducers are all reading correctly. We've seen whole racks pop off, the whole charge you just put in there because the discharge transducer was it was a low pressure instead of high pressure, and it was reading the wrong pressure. You didn't even know what it was reading. Nobody knew what it was reading wrong. It was saying it was good, but it was actually double whatever it was. You don't want that to happen. You just, another garment changing event. You're out there thinking that everything's perfect, and you haven't verified the transducers are reading the right pressure. Super important. Drains, door switches, lights, fans, little stuff. Making sure your gas cooler is wired and piped and the fans are going the right direction. That'll shut you down. You can start a rack up. By the time you get a full charge in it, you'll blow to pop off if your fans are going the wrong direction. It's happened, right? You had any of those, you guys? So. What are you looking for?
iCAD.
What's an iCAD?
The valve, iCAD valve, downfall stop? No? Is this everyone down the road?
Look on the side of the projector, the white ones.
Same white?
Oh, there you go.
Sorry, man, Paul told me to interrupt. Yeah.
Now he's buying the beer.
I won't come with you.
Last one here had to buy beer. That was the rule we had. He'll finish. Oh, they're good for a beer too. All right, so we got the evacuations done. We got the rack going. We got 25 minutes. We have to go really fast. But again, these things are elementary. Most of the startup steps we're doing aren't different for CO2. There's only a few things when you get to the part where you're actually running compressors and adjusting valves and making sure those things. The biggest thing I'll tell you is making sure you spend the time to make sure the rack, the piping, everything's clean, everything's dry, everything's leak-free, because we don't want to have to go back and shut it down. We want to keep the gas in the rack. Remember, keep the gas in the rack. And we do a lot of safeties. There's a lot of things built in there to help that happen, make that happen. It's amazing how many that we still lose because they didn't heed those warnings. So we did the triple evacuation, and we're gonna check our power, permanent power. Do you want to start up a CO2 rack on temporary generator power? Why? Because sooner or later you got to turn it off and switch it over, right? Sometimes that takes hours. Power company shows up and takes a break in the middle and the day, and you lose all the gas and you do start up again. A true story. We had a job site close to the plant one time. It was a prototype. It was CO2, ammonia, cascade, all kinds of stuff. But the plumber, who was the last one on job site that day, walked by the water tower and saw that the float was stuck open. Rack was charged, running, everything in the store running temp. We all had just left. Plumber walks by and sees the float stuck. He's a plumber. He turned the water off. He said, I'll fix this tomorrow. He turned the water off, went home. We get in the next day, everything's quiet. There's no sound of refrigeration anywhere. Water tower's off, it's out of water. Top cycle's off on head pressure. CO2 rack's empty, basically empty. Just vapor, a couple 100 pounds. All he did was turn the water off. But knowing what you do and planning ahead and talking about the service and stuff like that, it is super, super important. So the initial charge, you're going to need a few things. And again, we go in great detail about this when we do our own hands-on training and stuff. But making sure you have at least 2 liquid vapor cylinders once I got the vacuum ready to go. Why? You've already heard it. You guys already know. Why do I have to break the vacuum with vapor? Because anything under, technically, I'll give you the real number. Technically, it's 60 to 80 pounds somewhere. But we recommend a minimum of 150 pounds. You start from the vacuum, you get that circuit. If you get that circuit up to 150 pounds of vapor pressure, you have no chance and no worry of building dry ice in that system. It is a, if you like to, I loved dry ice when I was a kid. I like to put it in water. I like to do all those things. It's a very fun experiment, but unless you've got 4 or 5 extra hours that day, don't try what I'm telling you not to do.
Say that again, you said it was 60 PSI was the real number.
It's 60 to 80 something, somewhere around there. So, but we say 150. So now, if you're doing a service and you get it up 100 pounds and you can't, for some reason, somebody tell you, you have to be creative when you do service. So if I vent something out, or I work on a case and I vent that out, if I've got vapor to the suction line, you know it's vapor, you can barely crack that suction line, you can do it that way because it's vapor. But if you're on the rack and you've isolated like the flash gas tank, or you're changing the oil separator, you're changing the oil filter and the coalescing oil separator, you've let it down to 0. You've had the cap off. Now I got to pull a quick vacuum on it. And now I got to introduce vapor. So I can just put a gauge on there. I can put a hose on there and hook it to the suction line, and then just put vapor on to the thing till it gets over 100 pounds, 150 pounds, and then I can open everything up. It was on the liquid line. True story. Pro tip. So we had a liquid overfeed rack one time. It was in Dallas, Texas, middle of summer, and we had a leak. I don't know if any of these guys were here. We had a leak on the flange on one of the pumps. So it's liquid overfeed, so we're pumping CO2. And we had a leak on the liquid inlet to the pump. And we found the leak very quickly. It was loud, making those popping sounds and all that. And we isolated the pump. We quickly got the gas out. We got the liquid out. We fixed the leak. We had everything there on site we needed. A couple hours, we got ready to go back up and going. They pulled a quick vacuum on the pump because now it was voided. It was 0 pressure. Pulled a quick vacuum on the pump. Before we could turn around and say, don't do that, before you could say that, somebody reached down and opened the ball valve with the liquid above the pump. This is a $10,000 liquid CO2 pump. In about less than, you could say that, don't do that. The whole thing was solid ice all the way to both ball valves. It took 4 hours. We had to take all the flanges back off the pump. The whole inside of the pump was solid. If you ever see a picture of that, somebody showed a picture earlier today, one of the things. The whole inside of the pump, it was, if you try to run it like that, you would have just destroyed that pump. Yes, sir?
So on a pump system like that, you just need vapor bottles on site?
You don't have to, I haven't never seen a site that needed vapor bottles after the initial install,
But
startup.
If it's a pump,
If it's a pump,
if you have liquid pumps, you don't have suction, right?
well, you still have vapor.
Okay.
You can grab vapor from the top of the separator tank and run a hose to the pump.
Okay, so if you're.
You can vent it. Just don't open the liquid. Where I got liquid sitting in the ball valve above the pump, you can't open that up, right?
But if you're down to the cases,
If you're down at the cases, then you need to make sure you got vapor somehow, either a vapor tank or typically your vapor, if your rack's running and you've isolated a case, then you still should have vapor to your suction line. You can barely crack that. We've tried that and it doesn't. We did that in the lab just recently. We had to change the dryers inside the case.
No. It may not be suction, it'll be your return line.
okay, but you have vapor in it.
Right. That answer your question? Okay. Making sure. Oh, so the other tips are you're making sure you're charging hoses. If your unit, we always recommend this to end users and contractors. If your system's on the roof, remember, events are almost inevitable. It's a good practice to take a couple hours and permanently install a charging station downstairs. Okay? You can run a small line. It can be 3/8, quarter inch, whatever. 3/8 is better. Run 3/8 line with a ball valve or a hand valve down at the charging station. The best case is wherever they store the tanks. Then you don't have to move the tanks to the charging station. So if you come there on emergency call, even if they don't have tanks on site, you got somewhere to bring them. A full CO2, liquid CO2 tank weighs about 185 pounds. And it's only 60 pounds of gas, technically 60 pounds. It's not 60 pounds usable. They call them 60-pound cylinders. They weigh 185, 90 pounds. They weigh 120 pounds empty. So we know that because we weigh them in. And the only time you'll ever be able to tell how much gas is in the rack is when you put it in. But if you put a permanent station there, then you can recharge that rack with one person. If I don't have a charging station and a way to hook up tanks to it downstairs, then it's probably going to take two people to recharge a rack. What happens in the middle of the night? How many of you guys got somebody willing to get out of bed and come help you at 2 o'clock in the morning recharge a CO2 rack? Huh?
Not an emergency.
That's right. So the charging station, yeah, 4 or 5 guys. So, yeah. Again, most of the modern systems aren't 18 to get it back going because you don't ever lose the whole thing, right? Unless you have a catastrophic failure. A lot of times it's just a few tanks and we get it back going. You make sure if you got a charging hose or a valve station, that valve station's got to be good for 1,700 pounds because I'm putting straight liquid out of the tank. I'm not going through a regulator. I'm taking a hose from the tank, and we recommend that, and I believe it's on the next slide, that we always use a disposable liquid line dryer. And why is that? Remember we talked about debris and keeping things out of the system that shouldn't be in the system? Early days, pro tip, we were finding debris in our valves, our solenoids, our steppers, and pulse valves. We were finding debris in there that looked like rust. Well, like, there's no rust in the system. Where could this red dust be coming from that's stopping up all my strainers? It was coming out of the bottom of the CO2 tanks. We'd take a clean white rag and put it over the liquid tank and open the valve up, and there'd be a red ring around the rag. So it's venting out of the bottom of the tank. So if you use a small disposable dryer, it's really cheap insurance. Now I can strain out all the hard particles going from the tank to the rack, and I've got just CO2 liquid or vapor going in the rack. This adapter, that CGA 320, is super important. If you want to take a picture of something and get it out of the slide deck, that one's important. So that fitting is the same fitting that's on a CO2 regulator. It's the thread. It's a 3/8 thread, metal pipe thread, but it's not the same as refrigerant. It's not the same as nitrogen. It's a different thread pattern, and you can get that from most of the air gas suppliers, and I think Johnson has them and a few other people. But that's just the fitting. You still have to build the valve. You can get that fitting with a little stem that goes to a regulator, and you can put a regular refrigerant fitting on the end of that, and now you've got a charging port. And now I can go to that. I can adapt it to what this last contractor did. He adapted that to a metal pipe thread or a flare, and then we just screwed the dryer core right to that, and then put the hose on the other side of the dryer core, straight to the hose into the system. So you close couple. You don't want any of that debris going any farther than you have to. And we were finding debris in that fitting, that little 3 inches of fitting in between the tank and the thing. It's a good idea to dump that out in between charging if there's anything in there. So manual oil pump, again, don't try to pump it in under pressure. You'll waste a really nice brand new oil pump. Saw somebody bend 2 stems in one job site one time. Refrigerant scale, we talked about that briefly. It's really important. The only time you're ever going to know exactly how much gas you got in the rack is when you do it the first time. Because if you have normal events or you have a pop-off event or power failure or something like that, you just purge a little bit of gas. It's only a small percentage, of maybe 20, 30, maybe 40% of the load of the charge, but you don't know how much you lost and you don't know how much was in there originally. So if you weigh in the charge the first time, you tear it and you start breaking that vacuum and you put your tanks on there and it's real quick. It's just about as fast as you can charge it and you weigh it in. You won't have to do it again. At least you'll know. If I put 400, 500, 600 pounds of actual pounds, don't go by the tank. Because I will tell you from history and seeing hundreds of these tanks go across there, it's never 60 pounds. They charge you for 60 pounds. There may be 60 pounds in the tank somewhere, but the dip tubes and the tights and the things, once you get below the dip tube, you can't get it out. It just equalizes pressure, and the labor's not worth getting it out. You can heat it up, take it off, heat it up, and put some more in there. But once it gets below the liquid dip tube, it's not worth doing. So weigh it in, figure out what you got. If you're going to keep an emergency charge on site or at the supply house or at the thing, you'll know exactly how much you need for a full charge. And typically, you don't need that much. So the safety factor is, if I put 500 pounds in this rack today, and I've got 500 pounds available either here, part of it on site, and part of it at the supplier, then I'm covered. There are horror stories out there. We had a job in BFE, nowhere, I won't say what state it was because some of you probably know. They had an event, they had terrible power there, they had an event, they popped off, they used whatever stuff they had. They used the supply of the emergency supply gas they had, didn't replace it, didn't order new. A week later, it happened again. Of course, it happened at midnight on Friday night or something like that. The closest supply house that had the gas was 2.5 hours away, didn't have any. So now they've got to get it in. I forget what it was. It was the rack was down for 40 hours. The world's largest retailer wasn't very happy about that.
No.
It's not a good day when it takes 40-something hours. Now, some of those same folks are the ones that don't want to have those extra tanks on site or don't have anywhere to store them. You find somewhere to store them if you're down for 40 hours. Somebody's got to have the gas. So, I mean, they say, oh, we got it local supply. We got plenty locally. We got it at Airgas. We got it at Weldon Supply. But those guys come at 2 o'clock in the morning and let you have that gas? Tomorrow, maybe. Maybe Monday morning. This was midnight on Friday. It was Monday morning. They had to truck it in. They had to drive and get it because they couldn't even get a delivery. It's not set up that way. Yes, sir. Yes, sir.
That 40 hours, that refrigerated product in that grocery store, probably $400,000 worth of merchandise that they had to throw away. So when we talk about losing charge, and they don't want to spend the money up front, the consequence 3 years from now could be $400,000 again. Lose all the product, all the labor taken out, labor to restock it. It's really a big deal.
A couple thousand pounds of extra gas on site probably looked pretty small after that. But again, the $400,000 worth of food is priceless compared to, upsetting customers. You may lose customers over it, and that lasts forever. So there are other options. We always talk about keeping the gas in the rack. We'll jump ahead a little bit, but there are options. If you have an on-site generator, and you can put an ACU unit on there, which is a small horsepower, fractional horsepower. It's typically our lab rack. We've got one on our lab rack. It's 134A. That's going away eventually, but we're working on getting either A2L or propane. If we get a propane unit on there, it's still sustainable, and we can put it on a battery backup or just a power off generator. You can do either or. They're so small. I mean, they don't have much more power on it than a home refrigerator. Ours is 220, but you can get a battery backup, 220 battery backup, and it'll run it for 5 or 6 or 7 hours. I don't even have to mount a generator. I just plug it in, and it's on a pressure control. The control is very simple for the ACU, and when the pressure in the rack goes up, the rack shuts down on power, the ACU comes on. That's auxiliary conditioning unit. Those are keeping score. It's on a mechanical pressure control. So when the rack pressure goes up about 40, 50 pounds above set point, the ACU pops on. It doesn't matter whether the power's off or not. It'll still come on. It's just on a pressure control. My pressure control goes up. I got a mechanical control backing up. Remember, the power's off in the store. I don't want to rely on electronics for that. If my controller goes down, it'll still come on. So those help you buy you time. And if you're doing service and you have an ACU, think about it this way. You got to shut the rack down to change the oil filter. We talked about oil filter already. Good example. That happens semi-regular. You're going to do it at least once or twice in the life of the equipment. Maybe 30 days, 60 days, 90 days, depending on your customer spec. I got an ACU, middle of summer. I throw the ACU on. I pump the rack down. I can take my time changing the oil filter. If I don't have an ACU and I don't have battery backup, I'm on the clock. Tick tock, tick tock. And you're down there bent over the rack trying to change the oil filter. And again, another garment changing event because that thing is going to go off right there where you're working. And it's going to be loud, and it's a pretty violent thing. Yes, sir.
One more comment. The last 45 minutes of this presentation, it's all been about leaks and events that have happened. And that is the real knock on the CO2 industry, is what happens when you dump a charge. And just so everybody knows here, the numbers that Dale had up here, the 45 bar, the 120 bar, the whole industry is now meeting and trying to come up with an agreeable higher rating. Might be 60, might be 80, might be 90 bar, so that we can have a standstill pressure where we don't dump these whole charges. It's been a huge problem for the CO2 industry for the last 10 years. And now the big guys, the big retailers, you know who they are, have had enough of this. And now they're working with the manufacturers, and NISRC is leading the charge. We're having meetings right now trying to get a standard that will be higher to prevent this from happening. All these systems that are installed now, we're gonna have to deal with it. But hopefully in the next 6 months, we'll come to some agreement. And then it'll take some time for the manufacturers to change their tooling to get there. But we are working on this problem. And it's interesting to me that all the discussion here about the problems with CO2 was around leaks. It wasn't oil failures, it wasn't compressor failures, it wasn't controls. All you guys have been talking about leaks. But we're working on it, and hopefully in the next 6 months we'll have a solution.
There is a lot of work. There is a lot of work going on, for sure. But again, today, what we have available, the ACU, is very cheap insurance. It's a one-time cost, it's very low maintenance. These systems come on and off. They're standstill. You can keep the gas in the rack. Like I said, we got 2 labs, and we don't put gas in them every time we shut them down. We figure out how to do it. There's other ways. The 80-90 bar thing, it is a long putt. The industry's not ready for that. The component manufacturers, things, you got a long way to go. Like Ed said, it's a lot of work to be done if they go to that, and the price tag is way higher than the ACU. Many multiples. So just the upfront cost for install alone. So, and the equipment, because all the equipment goes up too. So it's very expensive. And the stainless steel is inevitable when we go to that as well because of some of the size restrictions. So there'll be more and more stainless steel. Oil charge, we talked about that, making sure. One key note here, and we're running out of time, is the oil levels are different in different compressor manufacturers. Make sure you know the difference. We've got racks with both Copeland and Bitzer on some of our test racks, and they're different recommendations. So make sure you know that. Initial charging, again, the oil. That's where I said the oil compressors. And I'm going the wrong way. Okay, so we talked a little bit about the CO2. We talked about when it gets below the dip tube, the tanks are very visual. This one happens to be a stainless steel tank. We don't typically recommend those, or they're very expensive and they're very hard to handle because they're like 250 pounds. But we have had to use those when we couldn't get steel tanks. But the symptom is the same. When you're charging the rack and the liquid gets below the dip tube, it's a very visual frost ring around the bottom of the tank. Once you see that ring, you might as well take it off because you're wasting more. It's costing you more labor to get the gas out of the rack than the gas costs. There's a couple of dollars left in there. So again, run out of systems. We send SOOs. Get a free SOO customized for your store and your rack with every new rack you buy. But the important part here is to know you need the SOOs. You need to understand the SOOs to give you the sequence of operation, what happens, this and that. It's good. I know it's like reading a friggin' legal manual, but it's important. It's really important for the EMS and the control guys, right? You got to have SOO. I don't know what to protect. I don't know what to set. No. I can't. This one's not specific to anything. So I can't zoom in from here. Those are just plastered into the thing. Again, ACU, we talked a lot about ACU. I've jumped around a little bit. We have startup forms, commissioning forms we do. Super important to know when you do a startup, whether it be factory assisted or not, that you record the settings. This is for DX or CO2. Record all your compressors, amperages, record all your voltages. So if you come back 6 months, a year, and you're having compressor problems, overheating, any of that stuff, that you can verify with what it was. If I had 20 amps on all 3 legs when I started it up 2 years ago, and now it's 26 on one leg and 10 on the other, there might be a problem, right? So yeah, those things are super simple and super easy. All the settings, we find a lot. These guys will go in, they'll do a factory assisted startup. We help them set and verify all the valves. We record all those valve settings. They say, the rack hadn't run right since we started it up. We go back, and none of the valve settings are the same as they were when we left them. So this information helps you confirm what that is. So really important there. These are just the sequence, and I know we always run out of time on these, but starting the compressors up, you always bring on which compressors first? Medium temp, because we're discharging the low. The medium temps are the condenser for the low temp. That's our booster system, right? So the low temp dumps to the medium temp dumps to the gas cooler, and so on and so forth, and here we go. Starting up compressors and starting up circuits, whether you're starting up for the first time or you're restarting after a power failure or you're restarting after a service event, is you have to bring the load on gradually. You have to bring the load on gradually. It has to start with medium temp load. And once you get a couple of the main medium temp loads on, you can start adding in a little bit of a low temp, but you need enough medium temp load to keep the medium temp compressors going. Sometimes they'll work, but you'll overheat a medium temp compressor if you're not getting any suction gas back. If you just you can't just dump discharge gas in there. You got to have a mixture of discharge gas and suction gas, or you'll overheat the compressor. And you can't bring that load on fast. So we set programs in there. They set emergency power outage programs where you bring on the most critical, typically red meat cases. Maybe it's a meat cooler, and then once you got a little bit of medium temp load on, we start bringing the low temp loads. You'll bring the ice cream cases on first, or maybe the ice cream freezer, the things that are most critical, and you're trying to get back down. The restart process and the initial startup process, it happens pretty quick. Once you get going, every 2 or 3 minutes, you can bring on another circuit, as long as you're not overloading the rack. If you see you're overloading the rack, then turn that circuit back off, and that'll take the load back off, right? So it's super important to meter that out, meter it in. Again, starting the compressors, charge capacity. We're going to bring it up above the separator tank, above the second glass. We do not want to run it more than 50% full. Ideally, it's between the first and second glass, which is somewhere between 25 and 50%. That's where you want. You got to have plenty of capacity there for the gas, the hot gas bypass valve, and the electronic expansion valve. Again, guys, I'm sorry we run out of time on these all the time, but make sure we don't have any evaporator temperature control. Defrost operation, real quick there. This is important if you're setting it up. Defrost schedules in general are the same defrost time. The difference is the pump out time. So liquid CO2 is very efficient. If I got a coil full of liquid CO2 and I shut off the pulse valve for off-cycle defrost in a medium temp case, what's happening while the CO2 is pumping out of the coil? The coil temperature may actually drop a couple degrees. So you got to add a little bit more time. So if I tell you, if you look at the service manual, just say it's a Kysor case, it's a service manual and it's 30-minute off-time defrost, you may have to go to 40-minute defrost. The customer's not going to see it, and you're not going to see it, because all you're going to do is give it 10-minute extra time so that it pumps out the liquid. I'm really not defrosting. I'm not defrosting the case until the temperature starts rising. So if you look at the graph, I can't tell you exactly what it is. It depends on the size of the system, the length of run. But if you look at the graph and you see it, it's 5 minutes, the temperature starts rising, then add 5 minutes. If it takes 12 minutes, then add 12 minutes. Because then I know that I'm rising temperature and I'm going to get enough of that termination time and enough of that defrost time to clear the ice. It's nothing more frustrating to start up a brand new rack and then half the medium temp cases are iced up the first week and I got to fix that, right? Because I didn't add the time to the stuff. Same with low temp. If you have electric defrost, it's a good practice to put a pump out time on there before I bring the heater on. Same thing. If I shut off the pulse valve and I turn the heater on, I'm using the electric heat to boil off CO2. I'm not doing defrost. I'm spinning both. I'm still running compressors to pump out the liquid, and I'm putting on the electric heat. So if you give it 5 minutes, 10 minutes on the pump out time, then bring on the heater, it'll save a lot of money, and it'll be a much more efficient defrost, and you'll reduce the frost load on the case inside. You've seen that, right? That's usually a symptom of too much defrost. Guys, we are out of time. I want to give everybody a chance. If you have any questions, anybody have anything right now? Troubleshooting. These are pretty elementary. We do have two facilities available. I told you about that. I think I got a couple of slides in here at the end of this. These are maintenance. This is the sorry. Yeah, that's that. This is the training center. This is the one in Columbus. We do have a live training center there with equipment and classrooms. And we will start putting a schedule out there, be on the lookout for that. And we also have the one here in California for you guys on the West Coast, where you can get a much more in-depth thing. I know I see a couple of people in here that have been there. I think Don Cole and A couple of guys have been through that class. Thank you guys for coming. Hope you have a good show. Thank you.